Lube oil becomes trip oil after passing through an orifice in the pipe which connects the pump discharge header of the lube oil system to the trip oil header. The orifice limits the flow of oil into the trip oil header when the system is in a trip state, but is sized to ensure an adequate quantity of oil for normal operation of all the trip devices. When the turbine is operating normally, the IGV solenoid valve is energized by the control system and its path to drain is blocked. Trip oil is therefore able to maintain normal pressure in the VIGV system. This allows hydraulic oil to modulate the variable inlet guide vanes according to the required schedule. The control system also energizes either the liquid fuel stop valve solenoid valve or the gas fuel stop valve solenoid valve, depending on which fuel system is in service. In this example, the liquid fuel stop valve solenoid valve is energized and trip oil can flow to the control devices in the liquid fuel system. The gas fuel stop valve solenoid valve is de-energized and trip oil is flowing to drain, which ensures that the gas fuel system is inoperative. When the turbine is started, the control system will energize the IGV solenoid valve 20 TV-1, allowing trip oil pressure to reach its optimum value in the VIGV system. This allows hydraulic oil to hold the variable inlet guide vanes in their closed position until the appropriate point in the startup sequence. The control system will also energize either the liquid fuel stop valve solenoid valve 20FL-1 or the gas fuel stop valve solenoid valve 20FG-1 at the required point in the starting sequence, depending on which fuel system is in service. This enables either hydraulic oil or trip oil to open the required fuel stop valve and allows fuel to flow to the turbine. The corresponding pressure switches will close, signaling the control system that trip oil is at its optimum pressure in the active fuel system. When the turbine is operating normally at 100% speed, the control system keeps the IGV solenoid valve energized. This maintains trip oil pressure in the VIGV system, allowing hydraulic oil to modulate the variable inlet guide vanes in accordance with the required schedule. The control system also keeps the appropriate fuel stop valve solenoid valve energized. This keeps the fuel stop valve open and enables either hydraulic oil or trip oil to operate the fuel system servo valves. Normally, turbine shutdown is initiated when the lead operator selects stop and execute on the operator interface of the turbine control panel. Throughout the shutdown sequence, fuel flow is gradually reduced to the minimum fuel stroke reference, FSR. Further reduction in fuel flow results in flameout of the combustion chambers. The flame detectors then signal the control system that there is a loss of flame. Once it is alerted to the loss of flame, the control system de-energizes 20 TV-1 and trip oil is dumped to drain. This causes the dump valve in the VIGV system to move to the dump position, and hydraulic oil bypasses the IGV servo valve and ensures that the variable inlet guide vanes remain closed. The control system also de-energizes either 20FL-1 or 20FG-1 as appropriate. Trip oil in the respective fuel system is dumped to drain, and the fuel stop valve closes, shutting off all fuel flow to the turbine. The trip oil system will remain in the trip state throughout the remainder of shutdown and cool down. The turbine protection circuits are designed to sense any abnormal operating conditions such as loss of flame, overspeed, overtemperature, high vibration, or high exhaust gas temperature spread. When any of these parameters are at an unsafe level, the control system initiates a trip by de-energizing 20 TV-1 and 20 FL-1 or 20 FG-1 as appropriate. The variable inlet guide vanes close and all fuel flow to the turbine is shut off immediately.